evening. I'm Calvin Joseph, and I'm a third-year research scholar at IIT Kharagpur. And today I'm going to conduct the Week 7 problem solving and doubt clearing session for the subject Electrical Measurements and Electronic Instrumentation, which was taught by Professor Abhishek Chatterjee of IIT Kharagpur. Okay, so what I will be going to teach about is what is an op-amp, what are the characteristics of the op-amp, like why an op-amp is used so much and it is considered like one of the very basic and integral part of a lot of circuits. And so what are the characteristics, the desirable characteristics of the op-amp, and how we can use those characteristics to help us to solve sums in an easy and fast manner. And then what is a difference amplifier? What is an inverting amplifier? Finally, what is a non-inverting amplifier, and what is the virtual ground concept? So the virtual ground concept is very useful when there's negative feedback, which helps us to solve sums easily. Okay. And then also we will solve some example sums and we will proceed. Okay. Now, start with week 7. So this week is completely regarding op-amps. Op-amps full form is operational amplifiers. Now, so this is a symbol of an op-amp. It has a minus symbol, a plus symbol. It has a plus V supply, minus V supply, and this is the output terminal. There's a point where Vn and Vp. Okay. N for negative, P for positive. Okay. So what are the characteristics of the op-amp which sir has taught to you in the lecture? Like what has been taught? So let us consider the static input to output characteristics of just the op-amp. Okay. So now an op-amp, first of all, is an active device. Because it requires a power source. So what is supplying power to your op-amp is your V sub and your minus V sub. This is your V supply and minus V supply. Okay. So they are the ones which are powering your op-amp, and it is not a passive device. Like a passive device is what which does not require any power. Like you have your resistor, inductor, capacitor. They will behave as a resistor, inductor, capacitor, even if you do not apply any power across it. Okay, they don't need any power to behave as a resistor, inductor, and capacitor. But your op-amp, if you want your op-amp to work as an operational amplifier, you need to provide it power, and that is by this plus V supply and minus V supply. Okay, now let us consider the input-output characteristics of an op-amp. So first of all, there are two inputs to the op-amp and one output. So there are two inputs and one output. So we can plot the output over here. Okay, what will be my input? There are two inputs, there's Vp and Vn. So what they consider is Vp minus Vn. Okay, the positive minus the negative. So for an op-amp, ideally, this should be, suppose this is your plus V supply, and this is your minus V supply. Okay. At a very small positive voltage, say let us say 0.1 volt. Let us say over here. This will go around plus V supply. Let us say if it is minus 0.1 volt, it will again be at minus V supply. And at a very small value of this difference, there will be a sort of line. Okay. So this is the input-output characteristics of an op-amp. And this comes about why? Because the gain of the op amp is very high. Ideally, it is infinite. But in practical sense, it is not infinite. So suppose your VP minus VN, let us say it is 0.1 volt, and the gain of your op amp, let us say it is 1000. So what will your V output be? V output is A into VP minus VN. Okay, that is 1000 into 0.1, that is 100 volt. Okay, that is not possible because your V supply is what is limiting your op amp. Okay, so what happens is your output voltage gets settled at plus 15 volt, will not exceed any further. Okay, so your output voltage will just be limited at plus 15 volt. Now, because it cannot go above 100 volt, so it will be stuck at plus 15 volt. And there is a small band over which the output voltage is not at the supply rails value. And this is a very small band. So now we will also check what are the various other characteristics of your op amp. Which it possesses. One, it has high input impedance. So what do you mean it has high input impedance? It means this is, let us say, your minus and plus, VN, VP, this current IN, which is going into the op amp, and this current IP, both IN and IP will be equal to 0. So no current can actually flow inside into the terminals of the op amp. It cannot flow inside. It is not allowed because the impedance offered by the op amp is very high. Ideally, it is infinite. So the current will not flow inside the op amp. Okay. Next is it has a high gain. The gain of the op amp is very high. Okay. That means what? If you apply like this, like it is around 1000 or 10 to the power 6, etc., it is in very high value. The gain is in very high value. So that is another advantage of the op amp. Third, it has low output impedance. So what do you mean low output impedance? Like we studied a practical voltage source. It will have some series resistance, right? It has some series resistance. So this is the output impedance. This is like the what do you say, the parasitic resistance in a supply in a voltage source. Similarly, this also would have an external resistance or some resistance there, but that value is approximately 0. It is very low. Okay. And that value is very low. So because of these characteristics of the op amp, it is very useful and very desirable. And that is why it is used a lot. So now, in a practical circuit, let us consider the practical circuit. Say this is my minus, this is my plus. This is some resistor R1. This is some resistor R2. Some resistor R3. Some resistor R4. Okay. Connected to ground. Let us say some V2 plus minus V1 is there, and this is your V output. Okay, this is an op amp. Now we will connect this circuit. Okay, is there anything missing? Can anyone tell me what is missing? Over here, what is missing? This circuit which I have connected, is there anything missing? Supply voltages are missing. So there will be a supply voltage plus and minus. So let us say this comes out over here. It could be like we say plus or minus 12. It could be plus 12 volt. Assume that is connected to ground. There will be another voltage source minus plus 12 volt, and that also is connected to this ground. Okay. So what is very important is all the grounds should be connected. So I actually in IT Kharagpur, I have to conduct some labs. So that time the students will use a breadboard and they will use an op amp and they will connect it and they will also use an input etc. They will do. So I'm actually teaching a low pass filter experiment where they use op amps. So what I tell the students is they should make sure that the grounds should be connected. There are three grounds. One is the supply, one is your input ground. These are the grounds of your input, right? This one, this one, this one. This is your input ground. Next, you have your output ground. You have your supply ground. Supply also ground is there, right? And where you measure your output also, there also is with respect to some ground. Okay. So there are three grounds. Input ground, supply ground, and output ground. So all of them should be connected. So it is basically kind of like a reference point. So what is a ground? It is the reference point of your circuit. Okay. So in a practical laboratory, when you will be running this experiment, whenever you'll be running an experiment, in case you have to first provide the supplies to your op amp, you have to connect the circuit and you have to make sure that all the grounds are connected. That cannot be neglected. That cannot be, ignored. Right? So that is one point. Now, also I told you that the input impedance of the op amp is very high. So the current which will flow over here is zero. Okay. This current is zero. So what happens is the current usually will flow like this. It will flow like this. Okay. It will flow like this. And this current will flow like this. So current cannot flow inside the op amp, but that does not mean that current will not flow in your circuit. So current will flow in your circuit, but no current will flow through your op amp. Okay. And one more fact is, so it has very high input impedance, and so they are like this connected over here. And in most of the sums which you will see, you will see that the negative terminal is connected to your output via some resistor or some capacitor or something. That stands for what is known as negative feedback. Okay, negative feedback. So one important concept is negative feedback. Let us say this is R1, V1. Let us say this is connected to ground. This is V output and this is R2. So, can you guys explain whatever you have heard about negative feedback? Like, is negative feedback good or bad?
Positive terminal should be grounded.
Sorry?
Positive terminal should be grounded.
It is connected to ground, yes.
Yes.
So what exactly is feedback? Feedback is this is my output. I am taking it back into my input. So now, like feedback in the case of these sessions. Now I am teaching all this. Then if you give me feedback saying like, sir, we are not able to see your pointer, or your handwriting is bad, we are not able to understand it, or your voice is not clear enough. So if you guys will tell me, sir, this is not what is happening, I'm facing this issue, or this part I did not understand. So you're providing feedback. So the feedback will come to me, and then I will learn how to change what I must do, what I must put into practice, what I must consider, and then it will be helpful for you. Okay, so that is feedback. From the output, we are taking some information and giving it back in the input. So let us consider over here. Okay, this is my output. Via this resistor, I am giving some information. Some information of the output. I am feeding it back to my input. So in some information of the output, I am feeding it back to the input. Okay. And why is it negative feedback? Suppose this voltage was, let us say, 4 volt. Okay. And this voltage over here was like 2 volt. Assume it was like that. So by chance, there was some disturbance. There was by chance some disturbance. So your 4 volt becomes equal to 4.2 volt. What happens over here? So what has happened? This has increased. Then this 2 volt may become like say 2.15 volt. So what has happened? This also has increased. Now when this increases, it is plus minus. So if this increases, what will happen? Your output will reduce. Your output will reduce. So what will happen? Your output will again go back to 4 volt. And this will again go back to 2 volt. Okay. So in that way, we have a stable operation. It is what is known as stable operation. Okay. So let me again repeat. Suppose my output voltage was 4 volt and at this terminal, the voltage was 2 volt. What happens because of some kind of disturbance or noise or something happens externally, this output voltage changes to 4.2 volt. It has increased. Then what happens is over here, it has some information of your output. So it also increased to 2.15 volt assume. Now what happens? The output of the op amp is plus or minus this plus this voltage minus this voltage. So as this voltage has increased, it has become, so that's why negative into the gain comes at the output. So your output has to reduce. So your output reduces back to 4 volt. And this also reduces back to 2 volt. So in that case, it is enabling what is known as a stable operation. Okay, it's a stable operation. So that is why negative feedback is very good. Now let us consider another case. Let us say this plus minus, this was connected to ground. This is R1, this is R2, and this is my V output, this is my V1. Okay, so your output voltage assume was 4 volt. Over here, the voltage is around 2 volt. Okay, now there is some disturbance, and this becomes equal to 4.2 volt. What happens to here? Here it becomes 2.15 volt. Now, your output is proportional to your V plus minus V minus, right? Now, what has happened is your output has increased. And because your output has increased, what has happened? Your V plus also has increased. What will this cause? First, your V output has increased. That causes your V positive to increase. That will again cause your V output to increase further. Okay. So that way, if it was 4 volt, finally it will go on, suppose this is your V supply, this is your minus V supply, it will increase and increase and increase to reach your plus V supply. You will finally go to plus V supply. Okay. So then finally your output will be equal to V supply. So I wanted my output to be 4 volt, but because of some disturbance, what happened is that the output has increased and that information has gone to V plus. V plus has increased further, and again it has caused my output to increase. And again my V plus has increased, and again that has caused my V output to increase. So it is like a cycle. Okay, it is like causing it to increase rapidly. Okay. So that is why positive feedback is like destabilizing it over here. Okay. So negative feedback is the one which is used in most op-amp circuits. In some circuits, positive feedback is used intentionally to achieve some operation, okay, which we have not considered yet, but you will soon learn about it in the future weeks. Okay, so till here, is there any doubts? Okay. So now, let me consider this is my op-amp. This is my V output. Let us say this is R1, this is R2. Let us say this is connected to ground. This is my V input. Okay. So because there's something known as negative feedback. Okay. As I explained negative feedback, right? So there is something known as negative feedback. Now, let us say your V output. Okay, let us say this is your V supply. This is your minus V supply. Let us say your V output is like say 10 volt. Okay, your V output is 10 volt. Okay. And your V supply is like some 15 volt. Minus V supply is minus 15 volt, etc. So it is within that band. Now, this is your V negative, this is your V positive. At that terminal, what is the voltage? So we know my VP is 0 volt. My VN, what is VN? I do not know. Okay. So now, this is a very basic circuit. This is like your inverting amplifier. This is your inverting amplifier circuit. Now we will consider what will happen. So, let us see. My V output is equal to some gain. Let us say the gain is A. The gain is A. And A is very, very high. Like let us say A is approximately 10 raised to 5. Okay. So my V output is A into VP minus Vn. Fine. Your V output is A into VP minus Vn. Now, what is your V output is 10? What is your A is 10 raised to 5? This is VP minus Vn. So VP minus Vn is equal to 10 upon 10 raised to 5. This is equal to 1 upon 10 raised to 4, which is approximately equal to 0. What does that mean? Your Vn is equal to Vp. Okay, your voltage at Vn is equal to Vp. And this is the concept of virtual ground or virtual short. Virtual short. So what actually is happening is we can consider that there is a sort of connection, virtual connection. It is not actually present, but because of the negative feedback and etc. in the circuit, it is connected. It appears connected, that they are at the same potential. One thing to note down is we can confidently say that my Vn is equal to Vp. And we know that the current flowing into your op amp is zero. Current flowing into your op amp is zero. Now, because Vn is equal to Vp, this Vn is equal to Vp, does it mean that some current can flow like this? Is it possible for some current to flow? Because it is like approximately like a short circuit. And what do you guys know? When there's short circuit, lots of current will flow. Huh? So does it mean that they're connected in short circuit like it is actually current can flow? No, current cannot actually flow because they are not actually connected. They just appear to have the same voltages at that point. So we can roughly say that my Vp is approximately equal to your Vn. And this is valid for most practical circuits where there is negative feedback in your op amp. Okay. So I like to say that this meeting will end in 10 minutes and then I will again restart this meeting. Okay. So now what I found out through this concept of the characteristics of the op amp and the characteristics of my circuit, I determined that my Vp is approximately Vn, right? So what can I do now? That means the current, whatever current flows, suppose there's some current flowing in, that current cannot go like this. It cannot go like this. It has to go like this. And it has to come here. And one more thing I know, the voltage at Vn is zero. I got to know that Vn is zero. So what I can do, let us say this is some current I. Okay, this current is I. So what I know current I is equal to Vn minus Vn upon R1. And since Vn is 0, my I is equal to Vn upon R1. Okay, I found out what is I. Next, I also know that I is equal to Vn minus V output by R2, right? I is equal to Vn minus V output by R2. So I have I is equal to Vn minus V output by R2. Now I know Vn is 0, so this is equal to minus V output by R2. And what is I? I we found out it is Vn upon R1 is equal to minus V output by R2. So what I got? My V output upon Vn is equal to minus R2 upon R1. So it is very simple. I did not have to do any complicated math, etc. I just used the concept that there is negative feedback in the circuit, that there is negative feedback, right? That there is negative feedback. Then I apply the concept of virtual short slash ground. And then I applied simply KCL and KVL. So this concept we will be using a lot for solving our example sums, our questions which are there, some previous year assignment questions we will be solving. Okay. So we have, this is the connection for a difference amplifier. Okay. So this your, let us say this is your V1, or let us say this is your V1 and this is your V2. Okay, it is like some plus minus V1 connected to ground, plus minus V2, which is connected to ground. There will be some plus V supply. There will be some minus V supply, which will be referred to this ground. Okay, that I'm not showing in this circuit, but they are there. So now, what kind of feedback is there in this circuit? Is it positive feedback or negative feedback? Is it positive feedback or negative feedback? Niranjan, Anumula? So it actually is positive feedback. Okay, positive feedback is in this circuit. Okay. So now, why? Because this output voltage information is coming over here at the negative terminal. That is why it is known as positive. Sorry, it is not positive, it is negative feedback. Sorry. It is negative feedback because the feedback signal is coming at the negative terminal. So now we can use the concept of virtual short. So these are effectively shorted. Let us say the potential over here is Vn, the potential over here is Vp. So I can say Vp is equal to Vn. Okay. That I found out. Now what I need to find out, one more thing to note down in the difference amplifier, these resistances should be same. This value and this value should be same. Okay. There should not be a mismatch. So what I can say now is, what is my Vp? How will I find what is my Vp? Can anyone tell me how will I find Vp?
V1
Vp is equal to V1. So one thing to know is
minus Vp by R1 equal to Vp by R2 equal to Vp by R2.
okay. Okay, fine. So what we have done is V1 minus Vp upon R1. So this current is equal to Vp by R2. That's right. So now what will I do? What I can do is Vp, I'll take common. So I'll get 1 by R2 plus 1 upon R1 is equal to V1 upon R1. So that is equal to Vp into R2 plus R1 upon R1 into R2 is equal to V1 upon R1. Right? So what I get is this R1 and R1 get cancelled. So Vp is equal to R2 into V1 upon R1 plus R2. Okay. And this is similar to the rule of potential divider, because the current is only flowing like this, right? So it is R2 upon R1 plus R2 into V1.
Yes,
So meeting will end in 1 minute and then I will again restart this meeting. Okay.
okay, sir.
So this I found for one current. Now the next current will flow like this. For V2, the current will flow like this, and it will flow like this. No current will flow from here. Okay, no current will flow into your input terminal of your op-amp. It will flow from here, it will come to your output. Okay. So now what I know is I know is V2 minus Vn upon R1 is equal to V2 upon Vn minus V output by R2. So I will write V2 minus Vn upon R1 is equal to Vn minus V output upon R2. So it is V2 minus Vn upon R1 is equal to Vn minus V output by R2. So what I will do, I will do V2 upon R1 is equal to Vn upon 1 upon R1 plus 1 upon R2 minus V output by R2. Okay. So that becomes V output, I take it this side, V output by R2 is equal to Vn into R1 plus R2 upon R1 into R2 minus V2 upon R1. Fine. Now what I know, by the concept of virtual ground, I know that my Vp is equal to Vn. And what is my Vp is equal to R2 into V1 upon R1 plus R2. So what I will do is, V output by R2 is equal to Vp into R1 plus R2 into R1 into R2 minus V2 upon R1. So V output upon R2 is equal to Vp. And what is my Vp? R2 into V1 upon R1 plus R2. So it is R2 into V1 upon R1 plus R2 to R1 plus R2 upon R1 into R2 minus V2 upon R1. So what happens? This R1 plus R2 and R1 plus R2 get cancelled, and this R2 and this R2 get cancelled. So it becomes V output upon R2 is equal to V1 upon R1 minus V2 upon R1 is equal to V1 minus V2 upon R1. So we get V output is equal to R2 upon R1 into V1 minus V2. Okay. So,
Okay, sir.
like, what is the advantage of a difference amplifier? Like, why do I have to use a difference amplifier? Already, we know that my V output is equal to A into V P minus Vn, right? Then why do I need a difference amplifier? Like, why do I want to add some resistors, which will carry some current? There will be some loss, there will be some power loss, heating, etc. Why do I want to add such things? So the thing to understand is this A in an op amp, it will vary. It is not fixed. It will depend on the temperature. It will depend upon uh, the op amp itself. One op amp might have gain of 1,000. Another op amp may have a gain of 1,020. It is all not fixed, and that gain is very high. Okay, it is very, very high. So it is not under our control. If we want to fix the gain, which we want, like let us say I want the gain to be only 1, or let us say I want the gain to be 2. So what I should do, I will set R2 to be equal to 2 times into R1. So what will that imply? It implies my V output is equal to 2 into V1 minus V2. Okay. So this is how I can set the gains. So any queries still here? Yeah. Okay. So now what will happen if we set V1 is equal to 0? If I set P1 is equal to 0, what will I get? I will get my V output to be equal to minus of R2 upon R1 into V2. This is the same formula as your inverting amplifier. Right? This is the same formula of your inverting amplifier. which we had considered earlier.
Yes, sir.
Minus and plus. So this VP was connected to your ground, and it was resulting in. So your inverting amplifier is a special case of a difference amplifier. Mhm. So now let us solve some sums. So let us consider this sum. Okay. Mhm. So this is now what is known as a two-input amplifier. It has two inputs. So does this look similar to what we have studied just now? Like what does it look like?
Differential amplifier.
It looks similar to a difference amplifier. But what is different? In a difference amplifier, what do we have? We have minus plus R1, R2 connected to ground. This is your V1, this is your V2, this is your R1, this is your R2, and this is your V output. But in this case, see this 1 kilo ohm and here it is 3 kilo ohm. And here it is 3 kilo ohm and here it is 1 kilo ohm. So they are different resistors. So this circuit which you have is actually plus or minus. This is your R1. Okay. This is your R2. It's connected to your ground. Plus minus 3 volt. But here it is your R2. 1 volt. This is connected to your R1. This is connected to your output. Okay, so it is a bit different. It is a bit different. And here it is your plus 14. Here it is your minus 14 volt. Okay. So now, one thing we have to understand is there is negative feedback. Output voltage information is coming as negative feedback over here. Right? So now, let us consider this terminal to be V positive. Potential here to be V positive. Here V minus. So what is V positive? The current over here will flow like this. Current will not flow like this. It will not flow. So what will be the potential at V positive? Can you tell me?
V volt.
V volt. Okay. That is one way of looking at it. But the actual fact is, some current will flow like this, right? So it acts as a potential divider. So let me say, what is this current? Let us say this current is I. So my current I is what? 3 volt, correct? Divided by R1 plus R2. And the potential over here is what? V plus is what? R2 into I2. So that is actually equal to 3 into R2 upon R1 plus R2. Okay. So now I have got V plus. Is there any issue on this? How did I get V plus? Okay. So now I've got V plus. Now there is negative feedback. I can apply the virtual short concept, short or ground concept. What does it mean? That this V plus and this V minus are sort of virtually at the same potential. So what I can say, what I know is now my V minus is equal to V plus, that is equal to 3 into R2 upon R1 plus R2. Okay. Now, there will be some current flowing like this, right? So this current, let us say it is I2. Okay. So what is my current I2? My current I2 is equal to 1 minus V minus upon R2, right? My current I2 is 1
Yes, sir.
minus V minus upon R2. And what is my, and also it is over here, my current I also is equal to V minus minus V output upon R1. Yeah. So I'll equate both of them. I will get 1 minus of V minus upon R2 is equal to V minus minus V output upon R1. So I will take V output by R1 is equal to V minus from 1 upon R1 plus 1 upon R2 minus 1 upon R2. But what is my V minus? My V minus is equal to V plus is equal to 3 R2 upon R1 plus R2. That will be V output by R1 is equal to 3 R2 upon R1 plus R2 into what? R1 plus R2 upon R1 into R2 minus 1 upon R2. So what I can do now? I can cancel. This and this get cancelled. This is not a good number. This and this get cancelled. R2 and R2 get cancelled. So it becomes V output upon R1 is equal to 3 upon R1 minus 1 upon R2. So my V output is equal to 3 minus R1 by R2. So what is my R1 and what is my, sorry, 3 minus R1 upon R2. My R1 is 1 kilo ohm, my R2 is 3 kilo ohm. Okay. So 3 minus 1 into 10 to the power 3 upon 3 into 10 to the power 3. So my V output is equal to 3 minus 1 by 3. So actually it is equal to 2.667 volt. Okay. So any doubts in this? Okay. So we'll go to the next question. So now how will we solve this sum? First, I noticed that there is negative feedback. Okay, there's negative feedback. If my output voltage information is coming at the negative terminal. Okay. One more thing I do is I will say this potential is Vp. This is Vn. This I've established. Over here, what is the voltage at this point?
5 volts, sir.
Here it is 5 volt, right? Now the current flowing over here is 0. The current flowing over here is 0, right? So now whatever current comes here, it has to go like this. It has to come like this. So this current, let us say this is I1. What is my I1 given as? How can I tell what is the value of I1?
One
Five
minus
minus
VP by
1 by
Okay, tell, both of you tell. No, none of you are telling.
uh,
Tell.
1 minus VP by 1 kilo ohm equal to VP minus 5 by 4 kilo ohm, sir.
It can be I1 is equal to 1 minus Vp by 1 kilo ohm. This color is not good. Or you can write I1 is equal to Vp minus 5/4 kilo ohm, right? Both these options are there. Or you could also write I1 is equal to 1 minus 5/5 kilo ohm, that is 1K plus 4K. So it is actually minus
सर
4.
यही हम बोल रहे थे
हाँ, both are
1.8 आ रहा है.
okay. So I1 is equal to minus 0.8. 0.8
Yes, sir. Yes.
milliampere. So all of you guys, there are different ways of looking at the circuit, all are right ways. Okay. I1 I got this is minus 0.8 milliampere. So what is my Vp? So I know Vp minus 5/4 kilo ohm is equal to I1, which is equal to minus 0.8 milliampere. So my Vp is equal to 5 plus minus 0.8 milliampere. So minus 8 into 0.8 and 10 to the power minus 3 into 4 into 10 to the power 3. Okay. Any doubts in this?
No, sir.
So the Vp is equal to 5 minus 10 to the power minus 3 and 10 to the power 3 get cancelled. It's minus 0.8 into 4, that is equal to minus 3.2. So what is my Vp?
वन पॉइंट एट
Yes, so Vp is equal to 1.8 volt. Okay. So now I have found out this voltage is 1.8 volt. And by virtual short or virtual ground concept, what do we have? These are effectively, you can consider them to have the same potential. Don't say that they are connected. You just say that they are at the same potential. So what I can say, my Vn is equal to 1.8 volt. So this is equal to 1.8 volt. So now you must understand current flowing over here is 0. But there will be some current flowing like this. And that current will not go here. It will go like this. So let us call that current I2. Okay, we will call that current I2. So what is I2? What can you say I2 is? I2 is equal to what? Tell me. You all can tell your answer.
5 minus
5
Five
minus 1.8 by 2.
So this 5 minus 1.8 by 2 kilo ohm.
equal to
So this is equal to
V0 minus Vn minus V0 by 4 kilo ohm.
okay, Vn minus V0 by 4K, right?
Yes, sir.
So
Yes, sir.
there is no requirement for me to find I2. I want to find V0. This is what is important for me. I don't need to find I2, right? So what I'll do, this is 5 minus 1.8 upon 2K is equal to 1.8 minus V0 by 4K. This gets cancelled, so it becomes 2. So this is 2 into 5 minus 1.8 is how much? That is equal to 3.2. Is equal to 1.8 minus V output. This is 6.4. It's equal to 1.8 minus V output. So my V output is equal to 1.8 minus 6.4. How much is that?
Minus 4.6.
So it is minus 4.6 volt. Okay. So is this some easy or difficult?
ये तो इजी है सर.
So this is easy, then the other sums also be very easy for you guys. Okay. So now, so you guys finished submitting assignment 7.
No, sir.
When is the last date?
Last date is 11.
11. That is Wednesday.
Yes, sir.
Yes, sir.
After today.
Okay. Achha. So both of you will be giving the exam, the test.
Yes, sir.
Yes, sir.
Okay. And when is the date for the final exam? Has it come out?
October, sir. Last.
27
Yeah.
October.
Oh, 27 October. Let me see. 27 October. That is Sunday. Okay. Achha.
Yes, sir.
And have you selected the center?
Dhanbad, sir.
Yes, sir.
Achha. So Niranjan, you are giving from Dhanbad. And Sangeeta, where are you giving it from?
Sir,
Both,
I
sir.
also.
Okay.
Batch, same batch, sir.
Same batch.
Yes, sir.
Okay.
Sir, actually, we are working. We continue our course with working professional course. We are in job.
Oh, yeah. Niranjan had told me actually. Yeah. Mhm.
Yes, sir.
Yes. So you have a class in the night, no?
Yes, sir.
Okay. Good. It's good. You guys are working so hard. Yeah. Very good.
Much more hard, sir.
Yeah. Because you have to work and you'll be tired, very tired after work, and then still you have to study.
Yes, sir.
Yes,
I
sir.
also have household work also.
Oh, you have family also?
Yes, sir.
Okay. And Niranjan?
मेरा भी ऐसे ही कुछ है, सर.
Okay. Yeah. So how many more years for you to finish your course?
ये तो पहला साल है, सर. अभी फर्स्ट सेम का एग्जाम देना है, सर.
अच्छा, और उसके
अभी
बाद?
हमको लग रहा है इसी मंथ या अगले मंथ होगा. मतलब थर्ड सेम का.
हाँ. Then another 3 more years, no? Means
3 years, sir.
3 years, okay.
Yes,
So you finished diploma, now you're doing engineering.
yes, sir.
Okay.
Sir, we are doing.
Engineering.
We already done diploma, and our job is in base of diploma qualification.
Okay. So where are you all working? Actually, Niranjan told somewhere.
Same plant, sir.
The Steel Authority of India Limited, Bokaro.
The SAIL.
Yeah.
Yes, sir. SAIL, Steel Authority of India Limited.
At where?
Bokaro.
Okay.
Bokaro.
Oh, अच्छा. Hmm. So you guys have all Monday to Saturday working or what?
Yes,
Yes,
sir.
sir.
And timing?
8:30 to 5 p.m.
Okay, okay. Oh. And then when is your college timing?
6 p.m.
College,
to 8 p.m.
6 p.m. to 8 p.m. Okay. Oh.
Sir, all the days are not in college. They are invite us at their schedule and not all the days.
Okay, you don't have college every day. Uh-huh.
Yes.
So like you have college only for practicals or even you have classes also?
both,
They
sir.
also gave us some practical classes, but not so much. But 2 to 3 days there are practical class, but otherwise all the theory classes.
Oh. Mm-hmm. Achha, achha. Okay, it's very complicated. Yeah. So we'll proceed then to the next question.
Okay, sir.
Mhm. So now this is my circuit. So tell me what feedback is there in this circuit? What kind of feedback is there?
Negative, sir.
So there is
Negative.
Hmm. So what I know, I can apply the virtual short of grounding concept. So I'll connect this. Virtually they are connected, right? So this is my VP, this is my VN. But this VN also is connected to V output. So what I have, VN is equal to V output. What I get, my VP is equal to V output, right? So now I have to find V output. How will I find it? So there is no current flowing here is 0. So what there will be some current will flow like this. Some current will flow like this I. So we find that value. So what is this current I? Can you tell?
3 minus VP by 5 kilo ohm
3 minus VP by 5 kilo ohm.
equal to VP plus 4 volt.
Sir, 3 by 5 kilo plus 4 by 10 kilo.
3 by 5. No.
सर ये पैरेलल पाथ में है ना, दोनों ऐड होके आई करंट हो.
नहीं पैरेलल नहीं है ना. पैरेलल नहीं है इन लोग. हाँ इन लोग पैरेलल में है एक्चुअली. हाँ पर हाँ पर करंट तो ऐसे ही फ्लो हो रहा है. सेम करंट फ्लो हो रहा है.
सर तो 3 by 5 plus 4 by 10 कर सकते हैं.
3 by 5 plus 4 by 10. नहीं क्योंकि वो जब आप यूज कर सकते हैं जब भी आपका ये करंट और ये करंट इधर जा रहे हैं एडिशन. पर वो एडिशन में नहीं है. ये करंट ऐसा जा रहा
Opposite direction में.
है. हाँ तो आपको केवीएल लगा दो. हाँ तो पहला या यहाँ पे हम लोग केसीएल लगा रहे हैं. क्या 3 माइनस VP अपॉन 5K इज इक्वल टू VP, फिर क्या VP और क्या
प्लस 4
VP प्लस 4
by 10 kilo ohm.
by 10 kilo ohm. So do the others agree? Is this correct? NS, Sangeeta?
Yes, sir.
What about NS? Yeah. So actually this is not correct. Why? Because this is VP plus minus V4 volt, right? So it will be minus V4. This is VP minus 4 upon 10K. Okay. Any doubts?
तो सर माइनस माइनस प्लस हो जाएगा ना सर,
नहीं मैं
दोनों का डिफरेंस।
आई एम गोइंग फ्रॉम यहाँ से यहाँ जा रहा हूँ मैं। हाँ, तो मैं प्लस से माइनस जा रहा हूँ इसलिए माइनस 4 आएगा।
Yes, sir. You took the last.
Yeah, the last sign only, no? We have to take the last sign.
Yes, sir. Yes, sir. It is minus 4.
So now what happens? This K and K gets cut.
दोनों का डिफरेंस ले रहे हैं ना सर।
हाँ, मतलब हम लोग क्या कर रहे हैं? VP minus 4 upon 10K, क्योंकि क्या हो रहा है, जो करंट जो फ्लो होगा उसको ये प्लस 4 वोल्ट अपोज करेगा, उसको रोकेगा, इसलिए VP minus 4 है। ठीक है, वापिस समझाओ कि और दूसरा मेथड से समझाओ इसको। ठीक है,
रिपीट कर दिए सर, थोड़ा सा डाउट है।
बेसिकली हम लोग सपोज हम लोग इस तरह हम लोग पहला KVL लगाते हैं। ठीक है, पूरा लूप का एक KVL लगा दें। हाँ, तो क्या हो रहा है, माइनस टू प्लस जा रहा हूँ तो 3, फिर -5K इंटू आई, -5KI, फिर क्या लिखता हूँ -10KI, फिर क्या लिख रहा हूँ प्लस टू -4 इज इक्वल टू 0। ये हुआ तो क्या हुआ, मेरा 3 - 4 इज इक्वल टू माई 15K इंटू आई। हाँ, ये एक लिख सकता
यस
हूँ।
सर।
अभी मैं ऐसा भी लिख सकता
ओके।
हूँ। तो क्या हुआ, ये -4 आता है, यहाँ पे -4 आएगा, +4 नहीं आएगा। और एक बात बोलना चाहता हूँ मैं कि ये जो 3 - 5 किलो ओम इंटू आई इज इक्वल टू व्हाट, माई VP, that is equal to VP, right? The potential over here.
यस सर।
Also I can write, so what I can write is this VP I can put over here. So VP minus 10 kilo I minus 4 is equal to 0. So which I can write it as VP minus 4 is equal to 10 kilo I. So that is my I is equal to VP minus 4 upon 10K. Okay, which is the same as this.
यस सर।
Okay, so that is how you must try to understand. So what you must do in this case is you must consider that there is a voltage source of plus minus VP. Okay, and you are doing the KVL of that. And when you consider in that aspect, when you look at the circuit like that, then you will get the correct equation. Okay, it's a fictitious voltage source, but that is what I use to get the correct values. So now what I will do is 3 minus VP, I'll write it as 3 minus V output is equal to V output minus 4 upon 2. Okay, so this is what 2 into 3 minus V output is equal to V output minus 4. So 6 minus 2 V output is equal to V output minus 4. So 6 plus 4 is equal to 3 V output. So 10 is equal to 3 V output. So what is my V output?
3.3, sir.
V output is 3.33 volts. Okay. So any doubts?
No, sir.
No? So now we will consider this question. So one point we noted down is there is negative feedback. Through this part, your output is being connected to your V minus, so it is negative feedback. Let us say this is my Vn, this is my Vp. So we know it is given that Vp is equal to 0. And by virtual short or virtual ground concept, we can have my Vn is equal to 0 volt as well. Okay. So now there is a current flowing like this. Okay, there's a current, let us say. This current will flow like this, like this, like this, like this. This is a current I. So what is it given? So what is my I? Can you tell me?
1/4 kilo ohm equal to
Equal to
2 minus V0 by 4 kilo ohm.
2 minus V0 by 4 kilo. Sangeeta, do you agree with him?
Sir, 1 minus Vn by 4. 4.
No.
Vp equal to 0 है ना.
अच्छा Vp is equal to 0 है तो Vn is equal to 0. तो 1 by 4 is equal to हाँ ठीक है सर.
Okay. Good, good. So now 4K and 4K get cancelled. So what I get? 1 is equal to 2 minus V output.
1 volt, sir.
So V output is 2
1 volt.
1 is equal to 1 volt. Okay. So now you
Okay,
guys have become so smart. You're solving it very fast. Very easy. This one. Okay. So now we will go to the next question. So again, if we notice, there is negative feedback. This is my V plus, this is my V minus. What is given? V plus is equal to 1 volt, right? And by the concept of virtual short, you can consider them to be shorted approximately or connected or at the same potential. So V minus is equal to 1 volt. Okay. That means over here, the voltage is 1 volt. So what will be the voltage over here? How will you find out?
V0 minus 1 volt by 5 kilo ohm equal to V0 by 9 volt, 9 kilo ohm,
V0 by
9 kilo ohm.
Okay.
Yes, sir.
Okay. Very good. So now what I do, this K and K, I cancel it. So I write 9 V0 minus 9 is equal to 5 V0, right? So I can write 4 V0 is equal to 9. So my V0 is equal to 9 by 4, so equal to 2.25 volt. Okay. So now my question is, what about this? Do they have any impact on the circuit?
No, sir, for calculating V0, it is not needed.
It is not needed. Okay. Mhm. Is currently not needed, right? Okay, so you guys have become very fast, very fast. So past 5 minutes, you're solving the sum. There may be no more sums for me to solve. So we'll go to the next question. Uh, so what is my V0?
2 volt, sir.
Sir, 4 volt.
Yes. Why? Because this and this is almost
Yes,
connected.
yes, yes, sir.
2
Yes,
volt, so 2
4
plus
volt,
2
4 volt.
plus 2
Right.
is equal to 4 volt. Okay. So wow,
Okay, sir.
we are going at a very fast rate. Super fast. So now let us consider this sum. So, right. So what do we have over here is this point is at 3 volt. Okay. What will be my V output? This, let us say this is your V.
V out, sir, 0 volt.
Right, sir.
So this effectively is like a plus minus 3 volt. 3 volt cancel, the current will be 0. So your V output also will be 0. Right?
Right, right, sir.
VP वर्चुअल शॉर्टिंग की वजह से एक 3 वोल्ट है और एक 3 वोल्ट और दिया हुआ है तो दोनों में कैंसिल आउट करके 0 हो जाएगा.
No, say.
Right.
Yeah. Okay. So this is, you guys are experts now. So now, 7 question, let's go to 8 question. No questions that was removed. Okay, so we'll consider this circuit. So this actually is 5 volt. Okay. There is again negative feedback. My VP, this is my VP, this is my VN. My VP is 5 volt. So my VN should also be equal to 5 volt. What will be my V output?
6.
6. Without solving, able to solve so fast.
सॉल्व करके बता रहे हैं सर.
Sir, 5 minus 4 is equal to 1 by 4 is equal to V0 minus 5 by 4.
So V0 is equal to 6 volt. Okay.
Yes sir.
So you guys are solving super fast. Go. Now, let's consider this question. So what do we have? This is your V plus, this is your V minus. V plus is at 0 volt. So V minus also is at 0 volt. Okay. Now what will we do? How will you solve?
सर I निकलना पड़ेगा. I is equal to 1 minus Vn by 4. Vn is equal to 0. तो 1 by 4 is equal to 3 minus Vn by 4. सर I is equal to इसमें तो Vn 0 है तो फिर 1 by 4 plus 3 by 4 होगा ना.
हाँ वो होगा वही 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 मैं बताऊंगा
फिर
था.
I निकल जाएगा तो I को 2 किलो ओम के अक्रॉस ड्रॉप मतलब के मल्टीप्लाई कर देंगे तो V नॉट आ जाएगा.
So your I actually is equal to 1 by 4K plus 3 by 4K. I is equal to 4 by 4K 1 milliampere. Your I also is equal to 0 minus V output by 2K, right? So your V output is equal to minus I into 2K. Minus 1 milliampere into 2 kilo ohm. So that is equal to how much?
-2 sir.
That is minus 2 volt. Okay.
Yes sir.
Yeah, so the sums are become very easy for you guys. You guys are becoming very fast.
ये टॉपिक थोड़ा सा इजी है. लगा इजी.
Very interesting also and very useful also topic.
Yes sir.
So this is your VP, this is your VN. Your VP is equal to 3 volt, right? Effectively, they are sort of shorted or connected. So effectively here we have plus minus 3 volt. Okay. Now, what will we do? How will we solve?
V0 minus 3 by 5 is equal to V0 by 5 plus 2.5.
minus
V0 minus 3
by 5.
by 5
Okay, pi k.
is equal to
V
V0 minus 0, मतलब अर्थ है तो 0 है, बाय टोटल रेजिस्टेंस ऐड करना पड़ेगा सर, 5 प्लस 2.5.
नहीं, वैसा नहीं कर सकते ना, क्योंकि वो 6 वोल्ट भी है ना।
वो 6 वोल्ट तो उसमें माइनस किया ना सर, टोटल का करंट तो सेम होगा ना सर।
नहीं, यहाँ से
6
करंट
वोल्ट को 3 वोल्ट से
V0 बाई 7.5 किलो ओम सर।
तो वो 6 वोल्ट है ना, और ये 3 वोल्ट है।
यस सर।
तो दिस एक्चुअली V0 minus 6 by 7.5 kilo ohm, you can write.
सर वो 6 वोल्ट तो नहीं होगा ना, उस पे 3 वोल्ट ऐड माइनस हो जाएगा तो 3 वोल्ट होगा नीट.
नहीं,
या इसे लिख सकते हैं सर, 3 बाई 2.5 किलो ओम।
हाँ, तो मैं बता रहा हूँ, तीन तीन तरीके से लिख सकते हो। ये जो
Yes, sir.
करंट आई है आप यहाँ से जा रहा है, ये जो करंट आई जा रहा है, आई कैन बी रिटन एज आई इक्वल टू V0 माइनस ये पॉइंट का पोटेंशियल कितना है, 3 वोल्ट, तो वो V0 माइनस 3 बाई 5 के। दूसरा बात है कि वी कैन राइट फ्रॉम हियर, तो 3 माइनस 6 अपॉन 2.5 के। दूसरे मेथड से लिख सकते हैं इक्वल टू V0 माइनस 6 अपॉन 5 के प्लस 2.5 के, 7.5 के। सब मेथड सही है, ऑल थ्री फॉर्मूलास आर करेक्ट।
यहाँ पे 6 कैसे हुआ सर,
इधर यहाँ,
लास्ट वाला स्टेप में?
क्योंकि मैं पूरा इसका कंसिडर कर रहा हूँ ना।
यस सर।
तो V0 माइनस यहाँ का 6 वोल्ट अपॉन 5 के प्लस 2.5 के। क्योंकि आप लिख सकते हैं ना, आप बोल सकते हैं कि अगर ये जो वी एन अगर ईबीपी 4 वोल्ट हुआ तो अलग हो जाएगा, ईबी 4 वोल्ट हो जाता, अलग हो जाएगा ना। इसलिए ये और यहाँ से करंट कितना जा रहा है, 0, तो ये बी आउटपुट, ये पोटेंशियल को मैं कंसिडर नहीं कर रहा हूँ, मैं एम कंसिडरिंग फ्रॉम हियर टू हियर। इस केस के लिए मैं यहाँ से यहाँ कनेक्ट देख रहा हूँ, तो मुझे V0 माइनस 6 बाई 7.5 के। इस केस के लिए मैं कहाँ से देख रहा हूँ, मैं यहाँ से यहाँ देख रहा हूँ। इस केस के लिए मैं यहाँ से यहाँ देख रहा हूँ, तो सब सही है, क्योंकि करंट तो एक ही करंट जा रहा है। मैं अलग अलग पॉइंट से मैं अलग अलग वैल्यूज देख रहा हूँ।
सर और एक बार रिपीट कर दीजिए इसको।
और एक बार रिपीट करता हूँ, तो पहला
यस सर।
ये भूल जाओ, ये पूरा भूल जाओ, ठीक है, ये सब भूल जाओ। ये पॉइंट समझ लो आपका VN है, ठीक है। और यहाँ से करंट 0 जा रहा है, 0 जा रहा है, तो मैं क्या बोल सकता हूँ, अगर मैं ये वाला कंसिडर करता हूँ, ये वाला, ठीक है, ये वाला केस, तो मेरा करंट क्या है, आई इज इक्वल टू V0 माइनस VN बाई 5 के।
यस सर।
अभी मैं ये केस कंसिडर कर रहा हूँ, ये केस, तो इट इज इक्वल टू VN माइनस 6 अपॉन 2.5 के।
यस सर।
अभी मैं ये केस कंसिडर करूंगा पूरा, that is equal to V0 minus 6/5 plus 2.5 to 7.5 K. ये भी हो सकता है.
Yes, sir.
ठीक है, all are equal, all are the same.
Okay. Okay.
अभी मेरे को क्या मालूम पड़ा कि my VN is equal to 3 volt because my VP is equal to 3 volt, right?
Right, sir.
So what I do, I will substitute over here. I will put 3 minus 6 upon 2.5 K is equal to V0 minus 6 upon 7.5 K. So what happens? K and K get cancelled. 2.5 and 7.5 becomes 3. So it becomes 3 minus 6 is minus 3 is equal to V0 minus 6 upon 3. So 3 into minus 3 is equal to V0 minus 6. So minus 9 is equal to V0 minus 6. So 6 minus 9 is equal to V0. So V0 is equal to minus 3 volt. Okay.
Okay, sir.
Sangeeta, have any doubts?
सर एक डाउट है, बैटरी का जैसे पोलरिटी सेम होगा तो उसमें ऐड होगा ना सर?
नहीं, तो मैं दिखा रहा हूँ, ये मेरा बैटरी है, ठीक है, प्लस माइनस 3 वोल्ट. हाँ,
यस सर.
क्या होगा कि जो करंट यहाँ से आ रहा है ना, वो उसको अपोज करेगा. समझ लो आपका क्या है, अगर
ठीक.
बाई चांस आपका प्लस माइनस 3 वोल्ट है एक्चुअली, हाँ, और यहाँ पे आपका
ठीक.
प्लस माइनस 6 वोल्ट है, और यहाँ पे आपका कुछ रेसिस्टर आर है, ठीक है, तो आपको क्या होगा, ये करंट क्या करेगा, जो करंट आई है वो 3 माइनस 6 अपॉन आर होगा, तो ये उसको अपोज कर रहा है.
यस सर, पूछ कर. यस
अगर
सर.
ये क्या होता है, अगर ये माइनस प्लस होता है तो ये करंट यहाँ से ऐसे जा रहा है, यहाँ से भी उसको और हेल्प मिल रहा है, तो आपका करंट क्या होता है, 3 प्लस 6 अपॉन आर हो जाता है.
यस सर.
तो इस तरीके से आप लिख सकते हैं. और
सर जैसे इस केस में सर,
हाँ
जैसे VP इक्वल टू VN हुआ,
हाँ,
तो आपका VP इक्वल टू है जैसे 3 वोल्ट, तो उस केस में मतलब इस टाइप से होता है. तो इसका मतलब पोलरिटी पोलरिटी किधर होगा सर इसका?
इसका मतलब
VN इक्वल टू 3,
इफेक्टिवली ऐसे,
VN इक्वल टू 3 वोल्ट हुआ.
हाँ, आपका VL इज इक्वल टू 3 वोल्ट हुआ. हाँ,
यस सर.
ये आपका 3 वोल्ट हुआ, ठीक है.
यस सर.
हम्म
तो इसका डायरेक्शन किधर होगा सर? किधर मतलब पॉजिटिव टर्मिनल होगा?
हाँ, तो एक्चुअली ये प्रॉब्लम क्या होता है कि जब जब भी आपको, ये समझ लो आपका VN है, ठीक है, ये आपका VN हो
यस
गया.
सर.
अभी आपको पोलैरिटी वो सब में कंफ्यूजन हो जाती है, तो मैं क्या करता हूँ, मैं KVL लगाता हूँ, वो मेरा कंफ्यूजन चला जाता है इससे. तो क्या होगा, KVL अगर
यस सर.
लगाऊंगा, अगर ये पोलैरिटी है, ठीक है, ये पोलैरिटी है, तो ये हुआ 3 माइनस टू प्लस 3, वापिस माइनस टू प्लस 6, हाँ, माइनस आई इंटू आर
यस सर.
इज इक्वल टू 0 हुआ.
यस
तो
सर.
मेरा अगर ये क्या होता, अगर ये होता प्लस माइनस, तो क्या होता है, 3 माइनस 6 माइनस आई आर. तो फिर मेरे को क्या समझ में आता है,
यस.
जब ये प्लस लेगा तो उसको अपोज करेगा, जब भी वो माइनस
यस सर.
लेगा तो उसको ऐड करेगा, उसको हेल्प करेगा, ठीक है.
यस.
हम्म ठीक है. So Sangeeta, you don't have any doubts?
No, no, sir.
अच्छा, so you're from West Bengal?
Yes, sir.
Okay, okay. And Niranjan, you are from where?
What, sir?
You are from which state?
झारखंड सर, रांची, झारखंड, रांची.
So, congratulations, we have finished solving the sum very fast. All 10
Yes,
sums.
sir.
So I think this time your assignment 7 will be very easy for you guys. You can
Yes,
solve
sir.
it on your own. You don't have to worry, no tension, no stress, nothing. Okay.
Yes, sir. Okay, sir.
So any doubts?
No, sir.
Doubts.
Sir, all these questions are based on virtual sorting. Is it need to check all time that is it in saturation zone or not?
You have to check because later on, I think sir will teach Schmidt trigger. That is actually has positive feedback. So in that case, you cannot use this virtual short concept. Okay, that's why when I was teaching you each sum, I was always pointing out that see, it is connected to the negative terminal. That's why I was always
Yes, sir.
Yes, sir.
it on you guys that there is negative feedback. And so virtual short can be applied. And then I apply virtual short and then I can solve the sum.
Yes, sir.
Yeah. So if virtual short is applicable, then it becomes very easy. So now, you guys tell me what is the circuit of a non-inverting amplifier?
Non-inverting amplifier means supply feedback should be taken from positive side.
Positive side? Yours,
Output is connected to positive terminal.
this your output. Then where will the
Yes.
resistor be? Okay, we consider this your resistor R1, resistor R2. Okay, this is my V input. This is one case. So is this possible?
No, sir. I think non-inverting means supply should be given to positive terminal.
Okay. Then what it should be? So the supply must be given here. So I should connect the supply over here. Like this. So first thing to remember is this is positive feedback. So this is not how it works. We are going to use negative feedback. Okay. So your output is directly connected to your negative terminal. And then we have R1 and then we have R2. Okay. And this is my input. Okay. So now what do I know? This is my this is my VN, this is my VP. So my VN is equal to V output. And what will be my VP? My VP will be equal to VN, will be equal to V output. So because there is negative feedback, that there is first negative feedback. Okay. And hence I can apply the virtual short or virtual ground concept. Okay. Now what do I know? This current has to flow like this. It has to flow like this. It cannot flow. Here current will be zero. Right? So what I have, V in minus Vp upon R1 is equal to Vp upon R2. Okay. So now what is Vp is equal to V output? So my V in minus V output upon R1 is equal to V output upon R2. So that is V in upon R1 is equal to V output upon 1 upon R1 plus 1 upon R2. So that is V in upon R1 is equal to V output into R1 plus R2 upon R1 into R2. So then this R1 and R1 get cancelled, right? So I have V in is equal to V output into R1 plus R2 upon R2. Hmm. So what is my V output? By V in is equal to R2 upon R1 plus R2. Is it correct?
Yes, sir.
Okay, I have some sort of doubt whether this is correct. We'll have to check this. To my knowledge, it is opposite. I'll check it. Hmm. Okay. So what I believe it should be actually V output by V in be equal to R1 plus R2 upon R2. That will make it 1 plus R2 by R1. Be like this. There is some way where we are making a mistake. Okay, I will check it and I will edit the slides accordingly. Okay. Hmm.
Oh,
Yeah. So I'll just consider a brief recap. So first, we understood the op-amp, how it is an active device. It requires a supply, plus V supply, minus V supply. Test two inputs. So it basically does Vp minus Vn, and it is and then what it does, these are the characteristics. Because it has a very high gain, that is why this part rises very sharply and then reaches the maximum and minimum value. Okay. And because, and so we saw there's high input impedance. That means the current is zero. This is very, very important when you solve the sums. We know that the current is zero. And there's a high gain, which results in what? Your virtual short points. Okay. Next, I told that the grounds, when you do a practical circuit, if you have practicals, the grounds should all be connected. Okay, all the grounds. Right, I'm writing. Okay, there's some issue which is not able to write, so I'll have to debug it, but I'll just tell you. So all the grounds should be connected. Then because of negative feedback, how negative feedback results in a stable operation. And so what do we have? And positive feedback destabilizes. And because of negative feedback and the high gain of the op-amp, we get a virtual short concept. And that is very useful in solving the sums. Then in difference amplifier, using virtual short concept, we have found a relation of V output by V input. Then we have also considered, then we have started solving sums. One is similar to a difference amplifier, but the R1 and R2 are not equal, they are interchanged. And then we found out the expression and then we solved it. Then similarly, for different complicated circuits, how we first see that there's negative feedback, then we apply virtual short concept. We also know that the input impedance of the op-amp is very high, so no current can flow into the input terminals of the op-amp. And then we use that, we found Vp, we equated it to Vn, and then we found the current and the voltages. Okay. So similarly in this circuit also, we solved them. And then that concept is repeated in all the sums. Okay. So that was what we used, and you guys learned it very well, and you guys were able to solve it very fast. Okay, another concept of how you consider the polarity of your battery, whether it is opposing your current or it is aiding your current, that also I explained. Okay. So with that, we can end the session.
Okay, sir. Thank you, sir.
Okay.
Good night, sir.
Good night. Good night. So actually there was a mistake in this circuit. What was supposed to be done is this input should be applied as the positive terminal, but these resistors will be in a negative terminal. Okay, that has resulted in the incorrect answer derivation. So it would be minus plus R1, R2. Here this is V output, and this is your Vn. So here also it becomes Vn, right? So this actually is equal to your ground, this your ground. So we have Vn upon R1 is equal to V output minus Vn upon R2. So you have Vn is equal to 1 by R1 plus 1 by R2 is equal to V output by R2. So we get Vn into R1 plus R2 into R1 into R2 is equal to V output by R2. So my V output is equal to Vn into R1 plus R2 upon R1. That is Vn into 1 plus R2 upon R1. Okay. So this is actually the correct answer. Thank you.